Today's problem is called pyramid transition matrix, and this one is all about building a pyramid step by step using strict rules. Imagine you are stacking colored blocks to form a pyramid. Each block is represented by a single letter. The rule is simple. Every upper row must have one less block than the row below it. Each block on top sits on 2 blocks beneath it. Now here's the twist. You are not allowed to stack blocks arbitrarily. Only specific triangular patterns are allowed. Each allowed pattern is given as a 3-letter string. The first letter is the left bottom block. The second letter is the right bottom block. The third letter is a block placed on top. For example, pattern ABC means A on the left, B on the right, and C goes on top. But BAC is a completely different pattern. Order matters. You are given 2 inputs. A string called bottom, which is the base of the pyramid. A list called allowed, which contains all valid stacking rules. Your task is to answer one question. Can we build a pyramid all the way to the top using only the allowed patterns? If yes, return true. If not, return false. Now let's talk about how to think about this problem. We start from the bottom row and try to build the next row above it. For every pair of adjacent blocks, we look up all possible blocks that can be placed on top based on the allowed rules. But here's the important part. There might be multiple choices for a single position. So what do? We try all possible combinations. If any combination allows us to continue building upward successfully, we return true. If every path fails, we return false. This is a classic backtracking problem. At each level, we generate all valid next rows. Recursively attempt to build the pyramid. If we reach a row with only 1 block, we are done. The key idea is, try every valid possibility, but stop immediately once a valid pyramid is found. That's the intuition behind this problem. In short, build level by level. Use allowed patterns to generate next rows. Backtrack if a path fails. Succeed if any path reaches the top. This problem tests your understanding of recursion, backtracking, and how to explore multiple possibilities efficiently. If this explanation helped, don't forget to like, subscribe, and check out the solution next. Let's move on and implement it. Example 1. Input, bottom equals BCD, allowed equals BCC, CD, CA, FFF. Output, true. Explanation, the allowed triangular patterns are shown on the right. Starting from the bottom, level 3, we can build C on level 2 and then build A on level 1. There are 3 triangular patterns in the pyramid, which are BCC, CD, and CEA. All are allowed. Example 2. Input, bottom equals AAA, allowed equals AB, AAC, BCD, BB, DEF. Output, false. Explanation, the allowed triangular patterns are shown on the right. Starting from the bottom, level 4, there are multiple ways to build level 3. But trying all the possibilities, you will get always stuck before building level 1. Today's problem is called pyramid transition matrix. We are given a bottom row of colored blocks represented as a string. Each character is 1 block. We also get a list of allowed patterns. Each pattern has 3 letters. The first 2 letters represent the colors of 2 adjacent blocks at the bottom, and the third letter represents the block that can be placed on top of them. Our goal is simple. Starting from the bottom row, can we build a pyramid all the way to the top, using only the allowed patterns? If it is possible, we return true. Otherwise, we return false. Key idea, the pyramid is built level by level. For every pair of adjacent blocks in the current row, we find all possible blocks that can sit on top of them. This means one row can generate multiple possible rows above it. So this becomes a search problem. We try all valid combinations using depth-first search, and stop as soon as we successfully reach the top. Step 1. Pre-processing allowed patterns. First, we organize the allowed patterns. For every bottom pair, we store all possible top blocks. This makes lookups fast when we build the next level. Example, if we see a pair A and B, we instantly know which blocks can go on top. Step 2. Build the next level. Now, given a row like ABCD, we look at pairs AB, BC, CD. For each pair, we fetch possible top blocks. Then we combine them to form all valid next rows. If even one pair has no valid top block, this path is invalid and we stop early. Step 3. Depth-first search. We now recursively try to build a pyramid upward. If the current row has only one block, we have successfully built the pyramid and return true. To avoid repeating work, we remember rows that already failed using a visited set. This optimization prevents exponential repetition. Final result. We start DFS from the bottom row. If any path reaches the top, the answer is true. If all possibilities fail, the answer is false. Why this works? Each level depends only on the level below. DFS explores all valid configurations. Memoization avoids repeated failures. The problem size is small enough for this approach. Closing. This problem is a perfect example of backtracking, DFS, state pruning with memoization. If you understood this, you've mastered a very important recursive search pattern. Now let's run the code and see it pass all test cases. Now the logic is complete. Let's run the code. All edge cases handled. Recursive paths validated. No repeated states. Submitting the solution. And there it is, accepted. Clean recursion, smart pruning, and a solid DFS approach. If this explanation helped you understand pyramid transitions, make sure to like, share, and subscribe for more daily LeetCode breakdowns. See you in the next problem.